we will get into the types of storage. So there are a wide variety of options, but the most commonly used options are the block storage, object storage, and the file storage. But I'll come to the other options, like there are table storage, queue storage, data lake storage, and so on. So we will get into that slightly little later. But for now, so these are the most commonly used. So we already talked about block storage last week, right? When we discussed about EC2 instance, we used that EBS volume, which is the elastic block storage option as part of your EC2 volumes, right? EC2 volumes depends on two type of storage options. One is this EBS instance, sorry, EBS volume, and the other one is instant store volume, right? So those are all the block storage option. So block storage option is mainly for your operating system and the application data and the database related content. So all these relevant data are stored in the block storage and you access it. So it is very much structured in a way. You might use operating system specific technology like NTFS or resilient file system from your Windows, or you might use ext3 or ext4, whatever technology that comes native within your operating system. You will use those file system technology, and you will create a fixed size chunks. This fixed size chunks is what we call it as blocks, right? So that is the reason it is called as block storage. So you use the native file system with that comes with your operating system, and you configure the block size based on the type of usage that you are going through. And if it is for the operating system, if it is for application or database, you size the blocks accordingly, and the file system will help you to create fixed size chunks and access the data. So the block storage mostly, I mean, it's like the block storage cannot be in a different data center, or it cannot be in the different location. So it has to be in the same data center, and it has to be accessible through the network, local network, and so on. So it should be there on the, I would say, on the intranet or the LAN itself. So there are different technologies that are there. So you can directly access using your local SCSI cable, or directly from the motherboard. You can connect it to a direct attached storage, where it is a kind of storage in a box, or you can also use some SAN storage capacity for your application data that comes from the storage area network, or you can also use protocols like iSCSI to mount those file systems and access it for your application database and operating system. So mostly the OS related content will be on the local disks on the server itself, either on connected to the SCSI cable, or directly on the direct attached storage. So comparatively, the block storage is slightly costlier. The reason it needs better performance and all those things. So cost is comparatively high because you use NVMe SSD or SSD disks, and the blocks are managed by OS. The file system format is managed by your operating system. So you will get a very high, very good performance there. Okay, so performance is really needed. It is very strong performance, or it is very, I would say, performance is strong there in your block storage. And this is mainly for the data that you frequently access when it comes to the access pattern, right? This is the use case for your block storage. So coming to object and just 1 second. Sorry, yeah, we'll continue. So the second major category is your object storage. That is where the S3, the Glacier, those options comes into play. So we will discuss the let's say the object storage today, and then tomorrow we will discuss on the file storage options. Okay, there is a minimal or a minor difference on how we differentiate the object and file storage. So object storage, it can get all the content, right? It can store any data type, okay, any unstructured data. It can be your files, Excel files or documents or PDF files. It can store all of them. So all the files, the content, we call it as objects in object storage. So that's the reason, like it is referred as object storage. So you can store any kind of data, video files, audio files, MP3 content, or MP4, or a document, Excel sheet, PDF, whatever, .txt file. It can be a binary file, or it can be any content, right? The object storage, it's like your Google Drive, right? Where you go and dump your pictures, videos, audios. So it is a equivalent in AWS. So we have S3 Glacier. So those are all equivalent to your Google Cloud Storage or Azure Blob Storage, your Google Drive. So it is very pretty much similar. So you can go and store any kind of data. It doesn't have any schema, right? You don't have to really worry about file system formatting like you do in your operating system. So this data, you can access it anywhere from the internet. So it is, I mean, this has to be there on the intranet only within your LAN, but this data can be on not only local area network, it can be accessible from the wide area network also. So object storage, like you are accessing it through the internet, right? The Google Drive. So you can access it anywhere from the internet. It is accessible anywhere, anytime. That is the benefit of this thing, anywhere, anytime access. Provided if you have your network connectivity, you can access it. So you can access it through HTTP or HTTPS, or you can use third-party APIs or third-party SDK tools, software development tools, kits for accessing this. For example, you might be using like OneDrive, Dropbox, and these are all some application which are all software development kits. There is a API for which through which you can go and access it. See, the Dropbox and all, initially they did not have their own storage. They generally used to have the backend as Amazon S3, and then they used to provide it. But now they have purchased some storage devices, and they have shifted towards having their own options. So similarly, Box and other options that you see, these are all technologies which are pretty much similar to S3. They provide you anytime, anywhere access to the storages. It doesn't have any schema. You can store and access data from the internet anytime, any you want it. So cost is comparatively less. Okay, I would say comparatively less, not comparatively less. When you compare it with file storage and block storage, it is comparatively less. Performance is moderate. It's not very strong. It's a medium performance is what you get. And then this is mainly for infrequently accessed data, I would say, not regularly accessed data. So once in a while you might access it. Some data, yeah, it depends. Like if you're frequently accessing it, it might get stored in a different tier, like a kind of standard tier. There are many different options within object storage. There is a standard tier, there is an infrequent access tier, and then there is a rarely accessed tier. I will explain in details on how you can differentiate between them. So coming to object storage, it is an internet based storage. You can store and access the data anytime you want it. This doesn't have any restriction in terms of schema. You can store video, audio, MP, in this pictures and documents, Excel sheet, binary text files, and zip files, compressed, uncompressed file, and so all those things, right? So only main difference between object storage and file storage is that these file storages are intended to be accessed as a network drive for your system, right? So you just do a map network drive on Windows, and then you do a mount file system on Linux, and so on, right? So this is, the protocol is different here. So you utilize the network file system or Windows server message block and all those technologies, right? So the file system that you use is different compared to your block storage and object storage, and this is mainly on your local area network or on the same network reachability. So cost is comparatively moderate. See, there are technologies that might be expensive. For example, some organization might use NetApp file system for file storages. In that case, obviously, the cost might be moderately high. But then, if you are using regular disks and network attached storage, so the NAS storage, you would definitely like the price will be comparatively lesser, right? This is mainly for infrequently accessed data, not for the regularly accessed data, but this is mainly for accessing the data from multiple different servers, right? So EFS access from multiple servers or users at the same time. So multiple users might have their home drive or departmental data. Multiple servers might store their common content in the network file system, and we might map it to the different servers, or map the volume, or mount the file system, or mount the drive and access it from different systems. So just for an example, users home data, the different business department data like HR, and all those departmental data, and common clustered content, which has to be, yeah, server shared data. So all these are examples and use cases for file storage. So file storage is pretty much semi-structured. It can accept different file systems or different file format, but there are certain restrictions in terms of the content size and all those things. So object storage is unlimited storage. Okay, there is no real limit. So virtually you can keep adding, but there is a limit based on the OS supportability and all those things. And here also there is a limit based on the operating system and the database size, application handling nature, and all those things. Based on that, the capacity will be different here. So today we are going to focus on the second category of option, which is object storage, which is pretty much I mean, almost all the companies use this object storage for different needs. Even as a personal individual user, we are also regularly using it, right? We are storing some of our pictures and videos and stuffs that we put it on the Google Drive or any internet storage like Dropbox or OneDrive. All these are object storage, so we are also routinely using it, and every single customer will have this S3 object storage solution for their business need. Okay, so coming to the requirement, so we need to understand the requirement. We need to understand the throughput, IOPS,